What's up, yo? What's up, people? Welcome to another stream. You already know who it is. It's your lovely host, Key, and I'm joining you today live from the middle of the ether, the interwebs. Check out my cool shirt. Hey, we're living big and doing it live, investing on my green screen. Oh, child, help me, Lord, please. Okay, so yeah, I got my little, shirt on. Let's just say that. I came to represent. Oh, not only that, what do we have here? Ooh, this shirt is good. I'm being silly, but this is super cool. I love this shirt. I also got a hoodie made, and I was just trying to get something made to kind of help me get in the mindset and really just get excited about this project. And I'm super cool, super excited. I mean, I am super cool. Super excited to have this stuff because it's super cool. And now I can walk around town and be like, yeah, look at my thing. And so, yeah, thanks for checking this out, and thanks for supporting the little thing I got going on over here. And I'm super nervous now. But anyways, we're gonna go ahead and get started with the stream. Oh yeah, a little housekeeping. I always say this every time I do one of these. If you go down below, there's a link to a survey. This survey is going to be used to help me improve the quality and the content of this channel. Only takes about 30 seconds to do. If you do that survey, I'll love you till infinity and beyond. Well, I love you anyways, but I love you even more. So it won't take too much time, and I really appreciate it. And it'll help me make great content that can help you as well. So yeah. Anyways, so today we're going to jump back into working on Boot.Dev. I was actually working on some like architecture stuff for a game idea I have. Um, I'm gonna probably do some of this type of stuff in another stream, but that's neither here nor there. This is what we're here for. So, last time when I left off, I actually did not submit this one, even though I had finished it. So I think I can just go ahead and run this and get the points for that. Yeah, for that question. Okay, so here's where we are. I wanted to get to level 33. I'm at level 31, which is going to be another 1,200 points, something like that. Another 1,300 points to get to the next level. So I do feel like I'm going to get there tonight. And on my way there, I have two XP potions and one of these quests I can do. So I'm going to try for the 2000 XP one, and I'm going to use. So I looked ahead a little bit. The next few ones are just like simple questions. So I think I can get through all these questions and get to this one and get a decent amount of XP. So that's going to give me a nice little chunk. So I'm going to go ahead and pop one right now. Wait, let me read the question first. Should you export code from the main package? Wait, I should read this. It's often seen that having been responsible for and have been responsible for throwing out code into packages without much thought. Oh, I've often seen. I've quickly drawn a line in the sand. Okay, different packages by definition, just for the sake of organization. Learning to properly build small, reusable packages can take your Go career to the next level. Yeah. If you're familiar with the pillars of OOP, this is a practice of encapsulation. So oftentimes, an application will have complex logic that requires a lot of code. In almost every case, the logic that the application cares about can be exposed via an API. Most of the dirty work can be kept within a package. For example, imagine you are building an application that needs to classify images. We can build a package classifier. So this is a function that classifies images, takes in an image in bytes, slice of bytes, returns the type of the image. So, okay. So colors, sure. Okay. We create an API by only exposing the functions to the that the application level needs to know. All the other logic is unexported, so to keep clean separation of concerns, yes. The application doesn't need to know how to classify an image, just the result of the classification. Yes. Don't change APIs. The unexported functions within a package can and should change often for testing, refactoring, and bug fixing. Okay, yes. So yeah. So that's the whole purpose of API. It's meant to be like the thing that allows something else to utilize what you have going on the inside, basically. Like a server, like the details of what goes on in a server, like the front end doesn't care. It just needs what it needs. And the server can do whatever it wants on the inside, as long as the API doesn't change. And the same thing is like with APIs that are in the form of packages. Long as the packages, things that it's giving you don't change, then the details of how it does what it does are really of no concern to the implementation. The unexported functions within a package can and should change often for testing, refactoring, and bug fixing. Well, a well-designed library should have a stable API so that users don't get breaking changes each time they update the package version. Yeah. In Go, that this means not changing exported functions signatures. Okay, so don't change the function signature. I Captain. Don't export functions from the main package. The main package isn't a library. There's no need to export functions from it. Packages shouldn't know about dependence. Perhaps one of the most important and most broken rules is that a package shouldn't know anything about its dependence. In other words, a package should never have specific knowledge about a particular application that uses it. Okay, okay. So I took an XP potion. Answer to this is no. I got 35 extra experience for that. Not too bad. Okay, this is the same thing. Okay, when should you not export a function variable or type? When should you not? Oh, yeah. What? Did I get it backwards? Okay, I got it backwards in my head. It's okay. I still got a bunch of XP. Okay, should you often change the package exports API? No. Try to keep the internal changes to internal functionality. Cool. Okay. What is concurrency? I'm telling you, orange juice and sparkling water get me through to my hydration goals. I don't even need a lot of orange juice. I just need like just a little bit, just a little twinge of flavor. Like in reality, I just want a soda. You know what I mean? But I'm getting old, so I can't be doing all that all the time. So I just trick my mind. It's like orange juice and sparkling water is like one step up from from flavored sparkling water, which is disgusting. Okay. Concurrency is the ability to perform multiple tasks at the same time. Typically, our code is executed one line at a time, one after the other. This is called sequential execution or synchronous execution. Yes. If the computer we're running your code, if the computer you're running your code on has multiple cores, you can even execute multiple tasks exactly at the same time. If you're running on a single core executes code at almost the same time by switching between tasks very quickly. Either way, the code we write looks the same in Go and takes advantage of whatever resources are available. How does concurrency work? I don't think this is true concurrency because there's concurrency and there's parallel processing. I think parallel processing is when things happen exactly at the same time on the clock, and I think concurrency is when things can be processed independently as cores are available, but they don't have to be processed at the same time. But I think they end at the same time. I recall, I feel like I watched a video about that. Let's look. Versus parallelism. Currency are both used to describe when multiple tasks are being processed, but they differ in a few key ways. Concurrency involves multiple tasks that start running and complete at different times, but in an overlapping manner. Okay, that's a better explanation than what I said, but that's kind of what I was hoping to say. But yeah, they do start, run, and complete at the same time, but in an overlapping manner. Concurrency gives the impression that multiple tasks are happening at the same time, but it's not truly happening on the same clock tick or something like that. I don't think, yeah, I don't know. Ah, does this have something to do with like the way the clock or something, the clock speed? I feel like it does. I feel like there's some. I gotta clock this. I'm gonna use cloud. I gotta keep this tangent real short because I don't want to waste my XP potion. Um, in concurrency is the clock speed responsible for determining. Wait, let's say in parallelism is clock speed responsible for determining for making. Let's just say two processes occur at once. Is it because of something related to that? I felt like there was some connection that I came across. No, okay, okay. Clocks. Oh, what happened? Unexpected capacity. Oh, they had too many questions at once. I thought I did something wrong. Oh, okay. Mm. I know you're trying not. I know you're not clocking my question. Did I do something wrong? Jeez, let's just use Gemini. It's fine. Gemini is fine. Okay, let's ask Gemini. Not directly responsible for making processes occur simultaneously. Instead, parallelism is achieved through the following methods. Modern processors often have multiple cores, each capable of executing instructions independently. Okay, cool. Okay. This allows processors to handle multiple tasks on threads concurrently. Okay, so multiple tasks can be handled on threads concurrently. Okay. Quad core processor can run four threads simultaneously. So, so a thread is a sequence of is a thread just a single what am I trying to say? In my mind, I'm imagining a thread as being like a single lane processes to utilize CPU. Like a thread is a way of organizing and processes. Is that correct? I don't know. I don't know what I'm saying. Okay. Okay. I feel so ignorant right now reading this. Okay, though. Threads within a process share the same memory space, allow them to communicate and synchronize more efficiently. Okay, I need to go back and like learn about CPUs because I feel like this is only ever going to make sense when I actually understand CPUs better. But I do understand the difference between concurrency and synchronous execution, and I think I understand the difference between concurrency and parallelism, but it's not like solid enough for me to be able to confidently speak on it. I'll say that. Okay, so a Go is designed to be concurrent, which is a trait fairly unique to Go. It excels at performing many tasks simultaneously, safely using a simple syntax. There isn't a popular programming language in existence where responding concurrent executions is quite as elegant, at least in my opinion. Concurrency is as simple as using the Go keyword when calling a function. So, okay, will be executed concurrently with the rest of the code and the function. The Go keyword is used to spawn a new Go routine. And Mello, we need to send a lot of network requests. Each mail must be we send must go out over the internet. There are millions of customers. We need a single Go program to be capable of sending thousands of emails at once. Okay. Oosh, excuse me. In my mind, I'm thinking like a program sending 1,000 emails is like a battleship, like launching 1,000 rockets into outer space or something. That's so cool. That's so cool to think that you can just spin up a bunch of different Go routines and they're all like separate concurrent processes. That's why I want to use GoLang for my game server idea. For this idea here, I'm gonna use GoLang because I feel like either GoLang or Erlang would be good, and I don't think I have the time to go learn Erlang or Elixir. Elixir runs on the Erlang VM. Elixir seems like it would be a great language to do this idea in, but yeah, GoLang is the one I know. So, but it seems capable. Okay, so each mode must go. Okay, so edit the send email function to execute its anonymous function concurrently, so that the received message prints after the. Okay, so so that the received message prints after the sent message. Okay, so we have a function called sendMail, and inside of it is another function. This is an anonymous function that will. Okay, so we have to make this a Go routine. So then both these lines will be evaluated at the same time. I think that's what it's saying. Cool. Huh. Okay. And so I know like you can use channels to communicate between um Go routines. Um and I think there's also something you can do to kind of like put a break or have them like break or something or wait in an idle state or something like that. There must be some way to do that. Like if you're waiting for one Go routine to do something that can pass to another one, but they don't happen at the same time, so one has to wait. Maybe there's like some async stuff you can do between them through the channels. Hmm. Okay, so channels. Oh, here we go. Wait, did I not get the credit for that? Oh, my bad. There we go. Okay. Um, so channels are a typed thread safe queue. Channels allow different Go routines to communicate with each other. Like maps and slices, channels must be created before use. They use the same keyword. Okay, so it's a channel for integers. Send data to a channel. The well, I don't even know what to call this. The back a dash. I love a good back a dash, you know? Yes. Come from a long family of back a dashers. So the back a dash receives it takes the number integer to the channel. It's a channel operator, not a bag dash. The data flows in the direction of the arrow. This operation will block until another Go routine is ready to receive the value. Okay. Receive data from a channel. Okay. Okay. This channel reads and removes a value from the channel and saves it to a variable v. This operation will block until there is a value in the channel to be read. Okay. So if your like code is going down and it gets to this, it's going to wait for the channel in order to continue um, running the code beneath it. Blocking and deadlocks. A deadlock is when a group of Go routines are blocked, so none of them can continue. This is a common bug that you need to watch out for in concurrent programming. This right here, he's like waiting for someone to pick up his value, but no one ever does. So I guess it never. All girl routines are asleep. I don't know why that's hilarious to me. I don't know why that's so funny to me. That's so silly. I think the Bagadash might be my new favorite syntax in GoLang. Yeah, absolutely. So that's my type of syntax. Go routines can get stuck waiting for a channel because it's waiting for one of the locks in the sync package. Wait for each other, none is able to proceed. Okay. Run the program, see that it deadlocks and never exits. The send is old function is trying to send a channel, but no other Go routines are running that can accept a value from the channel to send the old value. Wait, let me read this again. Run the program, you see that it deadlocks, never exits. The send is old function. Okay. It's trying to send on a channel. Okay. Okay, so okay. And but no other Go routines are running that can accept a value from the channel. So I need to start a Go routine. Um, I'm a little lost on this one. From the channel. So Go routines have to receive a value from the channel. Um, so this is the channel, and this is trying to assign the value to it. Um, hmm. Okay, so let's read from the top. So function called check mail age. It takes in a slice of mail, um, emails, and it returns a boolean, a slice of boolean. Yeah. Hmm. Okay. So it since it's old, this is going to this is a channel that receives a boolean. That's the type definition of old is old chan that can receive a boolean. And so should this be on a Go routine? Oh, I mean, I'm not quite sure how that fixed it. I guess, hmm, I'm not quite understanding how the channel. So a channel can pick up messages between functions. Is that what we're saying? Um, where's I wish Cloud is working. Hopefully it's working now. Oh, it's stood in my GoLang notebook. I'm learning about channels and GoLang. It seems like a channel allows data to be sent to it and um, accessible within the function, within the scope that created the channel. And the channel blocks a Go routine from a Go routine running until it receives its message. Okay, I got the basics right. Okay, thank you. Channels in Go are communication pipes that allow different Go routines to communicate and synchronize their execution. They're one of Go's core concurrent primitives, following the philosophy do not communicate by sharing memory, instead, share memory by communicating. Okay, so we create a channel, send data to the channel, receive the data from the channel. What is this? What the heck is that? I don't even know what that's supposed to be. Okay. So the main Go routine blocks to receives data. Takes 2 seconds before receiving data. Only after receiving data does the main Go routine continue. I'm gonna need it to redo this one. I think there's something weird going on here. They're type conduits that allow you to send and receive values between Go routines, lightweight threads. They provide a way for Go routines to communicate and synchronize their execution. So this is a Go routine that has a function that returns this message to the channel. The channel takes the message and they can print. Okay. This is an anonymous function. I love how anonymous functions look in Golang. They do look a little weird to me, but I like them. A little funky. Channels can be synchronizing mechanism. Uh, okay, so it's a channel that takes a boolean, and this go function is going to do its work, go to sleep. Okay, done. Um, Wait for the routine to finish. Um, this part here is kind of weird. So you don't have to point it to anything. You can just have it. Okay. What is close? I guess I don't know what close is. Um, okay, interesting. Okay, so I can submit this. Is there a way where I can see how long I have left on my potion? I don't think they have that on this. Okay. Oh, here it is. 6 minutes. Okay. I only by the grace of something special saw that timer down there. It is not obvious. I would expect it to like maybe be over here or something. Yeah, empty structs are often used as a unary value. Sometimes we don't care what is passing through a channel. We care when and if it is passed. We can block and wait until something is sent on a channel using the following syntax. Until it pops a single item off the channel, then continues discarding the item. Okay, so you're just discarding the item. That's what that meant in the previous example. Isn't able to boot until it receives the signal that its databases are online and it learns about them being online but while waiting for tokens. Empty structs on a channel. Run the code. It never exists. The channel passed to the wait for DBs stays blocked because it's only popping the first value off the channel. Okay, it should pause execution until it receives a token for every database from. Okay. Um, is this what I'm supposed to do? Just do it for each one? I don't know what I just did. Oh. Mm, I really don't know what I'm doing. Um, you receive a token for every database from a channel. Each time, wait for DBs. Reads the token. The okay, will print a message to the console for you. Um, okay, well, let's ask our little friend down here for some help. Can you give me a little help here, bro? I have baked salmon. I have it for a reason. Ah, greetings, young mage. I see you're working with channels and database synchronization. Let's think about this together. The current code only reads from the channel once. Yes. But according to instructions, we need to wait for all databases to come online. How many databases are we waiting for? That's right. This number of many. We need to do something multiple times. Okay, so we use a for loop. Okay. Um, that's cute. Okay, so remind me how to do a for loop for looping 4 times. What's the shorthand? I want to know the shorthand. I know the long way. Okay, you know what? You know what? The shorthand isn't much shorter. Or the shorthand is not really shorthand in it. Let's just use this. And we can do this. I'll just take this and put that in here like that. And like that. Hey, what happened? My music died? This right here is not working. Okay. Um, okay, so I should use DBs here. Okay, cool. So we're listening for the DB channel, and when it gets a message, then it unblocks the for loop to go for its next iteration. So in this code, it seems like DB chan is blocking the for loop iterations until it receives a message. How much time we have left? We missed it. Okay, so okay, that's pretty cool. I like this. I like this idea. Awesome. Did we submit already? There we go. 430. We're now level 32. Okay, let's see what we're doing on the quests. I'm close to getting the quest done. Okay, so I'm gonna try to go for level 33. It's still pretty early. It's only 8:44 here, so yeah, I think I can do it. I'm gonna take a little break, and then when I come back, I'm gonna get back after this. Don't go too far. Oh, excuse me. Don't go too far. But if you do go anywhere, welcome back to the Wolf Pack whenever you come back. Okay, I'll see you in a bit. Hey, what's up? It's DJ Key on 106.9 The Beats, and you're tuned in to another edition of Level Up. Boot.Dev. Y'all like that, didn't y'all? Y'all like that, didn't y'all? Okay, I'm just being silly. You know what? I would love to be like on the radio one day. When I was a kid, I used to think that that would be like the coolest job in the world. Some type of like broadcasting, like a character, play like a type of like character on the radio or something like that. Yeah, it's giving voice acting. Okay. Anyways, let's get back to this. Where we left off was we had turned this function into one that uses a loop here with the channel basically blocking each iteration of the loop until it receives um a struct from the channel or from this other from these go routines. Let me rewind. So this function down here is going to be sending empty structs to a channel that this over here will be waiting for to receive messages in. And while it's waiting to receive those messages, it'll block this loop from continuing to its next iteration. So as this is running, these Go routines may finish separately, you know, and this is going to wait. This basically is going to wait until the number of structs is the amount for the number of DBs it's waiting for. It's kind of a cool, it's a pretty cool interaction between these two functions. Um, yeah. So this is the Go routine, and inside of it, it's going to just loop through the number of databases. And every time it loops over, it's going to send in the channel an empty struct. Um, I don't think I understand. There must be something in their code that is making these two things run and receive the same number of databases. I don't think I understand quite how this channel ends up being utilized over here, but I guess that's part of the magic of this one. Yeah, there's something here that's not. There's something beyond this that's in the test that I wish I knew. Okay, so buffered channels. Buffered channels can optionally be buffered. You can provide a buffer length as the second argument to create a buffered channel. A buffer allows a channel to hold a fixed number of values before sending blocks. This means sending on a buffer channel only blocks when the buffer is full, and receive blocks only when the buffer is empty. Receiving blocks only when the buffer is empty. Okay. Okay. We want to be able to send emails in batches. A writing Go routine will write an entire batch of email messages to a buffered channel, and later, once the channel is full, a reading Go routine will read all the messages from the channel and send them out to our clients. That's cool. So it's like a way to do a batch, and a channel will wait for its buffer to be full, and that's how you know what a batch is done. It should create a buffered channel. So, and 100. Okay. Write the emails. Okay, so for range or for the range emails, and then there's still something broken, but I do need to have this here. Oh, the size should be oh, and s- cannot use as an int value. Um, oh, okay, so I can't do. Yeah, I can do that. Oh, this should be string. My bad. Cool. Yeah, I was like copying this and I didn't change that part. Okay, cool. So then something else will be using this channel or something. Okay, we got the points there. That was good. Okay, so we got this close to close a channel. Okay, channels can be explicitly closed by a sender. Let's see what questions we have coming up next here. Maybe we can use our other XP potion. I think I'm just going to use it. And I think we are going to get to level 33 if I use it. Let's check our. We're close to that too. Okay, cool. How am I doing on sharpshooter? Okay, I did miss one, so it got reset. Channels can be explicitly closed by a sender. Channel, so this is making a new channel. It's not buffered. Do some stuff with the channel and close it. Similar to the OK value when accessing data in the map, receivers can check the OK value when receiving from a channel to test if the channel was closed. Okay, literally. Okay is false if the channel is empty and closed. Don't send on a closed channel. Sending on a closed channel will cause a panic. A panic on the main Go routine will cause the entire program to crash, and a panic in any other Go routine will cause that Go routine to crash. Closing isn't necessary. There's nothing wrong with leaving channels open. There'll still be guards collected if they're unused. They should close. You should close channels to indicate explicitly to a receiver that nothing else is going to come across. Okay. MLOs were all about keeping track of what our systems are up to, with great logging and telemetry. That's a $5,000 word. Telemetry. Hmm. The send reports function sends a batch of reports to our client and reports back how many were sent across the channel. It closes the channel when it's done. Complete the count reports function. This one here. Use an infinite for loop. Okay. I think you can do it like that. Okay, so if okay, then we'll break out the loop. Okay, so we don't need the value. Oh wait, the number of reports will come in, so it will be the value. So we just return V. Um, okay. Maybe if I just do like this. Um, okay, so let's do 0, and then we'll okay, else. Okay, wait. So if it's okay, then we increase number sent. How do I break out of a loop? Is it just break? I'll just use their thing. I gotta use my SAM anyways. Let's do it. Okay. Yeah, that's what I was doing. So if it's not okay, then we break. But if it's okay, uh, yeah, we'll break. But we still need this okay variable. Um, okay, so I think we can do this. We just replace this with V every time, and then at the end we return sent. And we can just initialize this as a int, like that. Or is it like this? Oh, it's like that. There you go. Echo. No, I didn't do it. Hmm. 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 Well, let's see what it tells me. Replacement of the break. Breaking out the loop on the first iteration. Oh, okay. Okay, so I gotta reverse this. So if it's not okay, then we break. Otherwise, we do this. Okay, let's try that. Yeah, okay. Not a big deal. I should have used my potion. Similar to slices and maps, channels can be arranged over. Okay. The sample will receive values over the channel, blocking at each iteration if nothing new is there, and will exit only when the channel is closed. It's that time again. Melo is hiring, and we've been assigned to do interviews. The Fibonacci sequence is Melo's interview problem of choice. We've been tasked with building a small toy program we can use in the interview. Complete the concurrent fib function. It should create a new channel of ints. So we'll call this int chan. Sure. It's not buffered. Call Fibonacci concurrently. Excuse me. Okay, so we need to loop over. Okay, so or um, I don't know what I'm supposed to call it. So let's just call it I. Let's just call it um, V. Let's just call it channel CH. Okay. So we're gonna range over the channels of the channel, and it's gonna keep going until the channel is closed. So all we have to do is call Fibonacci here, and we need to give it the um, and give it in, I guess, and the channel. I'm confused. Return the slice. So is the channel the slice? I don't know why this isn't clicking for me. Okay, complete the current concurrent fib function. We should create a new channel of ints. Okay. Um, should I do this? Because that will make it that long. And then now it'll be ranging over at least that many times. Okay, so let's make a new slice of ints like that. That's what I need to do. And then here we do append. Um, on append, then we can put this here and put ints here. Is that what I'm supposed to do? Ooh. Oh, and then we gotta return it. Um, what am I supposed to do with these values? Oh, maybe I'm supposed to put the value in there. Oh, okay. So when this is called, okay, so n can go here, n can go here. So when this is called, I need to take the number from the channel and I need to, oops, got that backwards. We take the number from the channel and then we need to append. Did I make it freeze? What did I do? I caused an infinite loop. Okay, so this is going to do Fibonacci over all of the. So do I need to do go like that? That didn't help. Oh gosh. Well, let's use another big salmon. I got 12 of them. That's what they're there for, right? It says it could be called once before I start the for loop. Oh, um, okay. Can I get the index from here? Um, okay, so I can't do that. Um, mm, okay, so we don't have to do this inside of the loop. We can do that out here because this is gonna do a loop and stuff on its own. Oh, my music stopped. Let's get the music going again. YouTube's like, are you listening? Are you really there? We know people fall asleep to this. Okay. I'm definitely breathing heavy. I think that this is what I need here. So this needs to be outside because this is gonna do a bunch of different Fibonacci things that are all gonna feed to this channel. And then this loop is just gonna wait for the channel to receive a message. Then it's gonna assign that message to now the part where I'm tripping up is I need to get these inside of this int. I think if I just initialize this as an empty construct for ints like that, then I can do the append here. I think this might work. I think this could work. Bull beans, I got it. I get it. Well, I don't know if I get it, but I definitely got it. I got something. Okay, let's go ahead and submit this. Whoa, whoa, whoa. Okay, that's what I'm talking about. Been streaming for an hour and 20 minutes. Okay. Uh, oh, we got the treasure chest. I got it. Let's see. Sharpshooter reward. 3 gems, 1 frozen flame. And we got daily quests. Reward. 9 gems, 1 seer stone, 1 XP potion. Oh, that was nice. Look at me. I'm over here balling. Balling. Okay. Sometimes we have a single go routine listening to multiple channels and want to process data in the order it comes through each channel. The select statement is used to listen to multiple channels at the same time. It is similar to a switch statement, but for channels. Okay. So this will just listen to these different channels. Okay. Until they're closed. The first channel with the value ready to be received will fire, and its body will execute. If multiple channels are ready at the same time, one is chosen randomly. The OK variable in the example above refers to whether or not the channel has been chosen by the sender yet. Okay. The one that's OK and receive something. Okay, so use a infinite for loop and uh, s- and the select statement. We need two of these. This song is terrible, by the way, but it's fine. It's copyright free, so I'm not gonna complain. Okay, so and select the statement to log the emails and SMS messages as they come in order across the two channels. Add a condition to return from the order when one of the two channels closes, whichever one is first. Okay, so I gotta wait. Okay, so I just gotta call log SMS, I guess. Um, okay, is that what I'm supposed to do? And then when one of them closes, okay. So closing mean is a message being received still. I think I can do if not, okay, return. Is that what I'm supposed to do? Oh, these are supposed to be the like this. My bad. Do I have okay, so I do have infinite loop, but it's getting stuck. Um okay, so this one should be SMS. Okay. Seemed like that worked. Oh, we did it. So okay, okay. So if I had not used the value here, then it probably would have done an error. Okay. Select default case. Ooh, I'm getting tired. I might need another break here, and then maybe we can try for the last half of this. I'm gonna do this question. I'm gonna take a break. I don't want to be up all night tonight either. The default case in a select statement executes immediately if no other channel has value ready. The default case stops the select statement from blocking. Okay. Ooh, that's cool. Sends a value once after the duration has passed. Blocks it. the current Go routine for the specified amount of time. Can you mark this read only by casting it from channel to a chart? Okay. Okay. So if you don't have the spaces, if you want, wait. Oh, I see. Okay. So right only means the arrow's pointing into the channel. Read only means it's pointing away from the channel. That's interesting. So what if you want to read and write? So bidirectional has no little arrow thing. Okay, cool. Okay, so like all good backend engineers, we frequently save up or save backspace snapshots of Mailo database. Complete the save backups function. Okay. If a value is received, it should be values from snapshot ticker. Okay. And call take snapshot. And snapshot ticker is not here. Okay. Hmm. A value receives from so if okay, so we need to make a let's start off by printing. I need to see what snapshot ticker is. Okay, I can't do it. Okay, because it's being blocked. I see. Okay. Well, if a value is received from, so I can just do this. I think I can do this. I don't know what I'm doing. Let's get some more help. Help me out, little buddy. Is that a bear? Okay. Oh, snapshot ticker. It's I'm so confused. I thought that this was only for save after. These are both channels. Ugh. Okay. So what I need to do is a select, and these are read-only channels. Okay, so what was the syntax for that, by the way? Case. Okay, let's just do it in here. This music is way too lit for a Sunday. I'll say that. This makes me want to go to bed and like turn this off and be like just done with the day. I'm just like, come on. Let's do no copy, right, chill. I get something that's like a little more chill. Best of chill mix. Sure. It's by the same people. Oh, that's interesting. Um, read and chill. That sounds great. That's perfect. Ain't that nice? Okay, so we need to do a select statement, and we need to send the we need to send the channel messages to it. So snapshot ticker, and then we take a snapshot, I guess. We got another one of these for save after. Um, save snapshot and return from the function. Okay, so if so default, um, and we'll just have the default time about sleep for 500 milliseconds. Do we have time up here? Okay, let's run that. Uh, nope, I did something wrong. Maybe we need to store. Um, Okay, let's see what it's going to tell us now, I guess. Oh, I need to put this in a for loop. That's what I forgot. Okay, so this needs to be in a for loop. And this all needs to be tabbed over. We're getting somewhere close. Oh, I gotta have a message, I guess. Okay. Um, waiting. Oh, I gotta call waiting for data. Does that mean anything? Wait for data log chan. Okay. These gotta be go routines. I don't know why I did that. That did make probably didn't make any sense. Um, okay, wait. If a value is received from snapshot ticker, call snapshot. I did. If the value is received from save after, call save snapshot and return from the function. You're done. If neither channel has a value ready, call wait for data and then time sleep. So it seems like it's not getting blocked for some reason. Do these need to be like this? That didn't make a difference. Oh, so time dot millisecond times 500. Okay, that's what I was doing wrong. Okay, they didn't really ever teach how to use the time package. but that's good to know. Okay, so let's try to run it. Cool. I got 500 XP for that. Wow. I'm very close. Okay, so I'm gonna take a little break here, and then when I come back, we're gonna try and knock out the rest of this level. Let's see. And we're getting pretty close to this being done too. So once we get down here, I can pop one of these XP potions and yeah, we'll be good. I'm gonna aim to get one of these challenges done, both of these reviews and one of those challenges, and then we'll see how it goes from there. Okay, I'll be back. Give me like 10, 15 minutes and don't go too far, but if you do, you can always come back to the wolf pack. See you in a bit. Hey, yo, what's up? I'm back. I'm back. I went and got me a little bit of a snack, and I brought some snackage with me as well. Looks like my light needs to be fixed. If I turn this one off, I think we'll be good. Yeah, there we go. Just had too much light. Okay, yeah, I got me some applesauce here. I love applesauce. Let me just say that. I just simply can't quit. It's so good. Yeah, so good. I could, if I did not watch myself, I would eat this entire jar of applesauce. I don't even bother putting it in a bowl or anything. I just eat it straight out the jar. Okay, so what happens if you read from a no channel? Um, Rob Pike. Who is Rob Pike? This must be like a programmer joke. Okay, let's go ahead and read this. Here are a few extra things you should understand about channels from Dave Haney's Ross awesome article. Let's take this article and do what I do. Oh, let's just read it then. I was gonna like say if it's really long, I'm just gonna put it in Claude, but we can skim through it. Send to a no channel blocks forever. Receive from a no channel blocks forever. Is no the zero value for a channel? Hmm. Somehow I feel like if I was eating this in color, it would be way grosser. But since I'm eating it in black and white, you're somehow spared from all the disgusting details. Yet I refuse to not eat on camera because I know that I'm not the only person out there who eats on the computer or while you're on the computer. Okay, let's be real. We all do it. Okay. Send to a closed channel panics, which will stop your program altogether. Okay. This will deadlock here. Um, oh, okay. I think I get it. So declared but an uninitialized channel is nil, just like a slice. Okay. Okay. Ascend to a nil channel blocks forever. Okay. Or receive from a nil channel blocks forever. Ascend to a closed channel panics. A receive from a closed channel returns to zero value immediately. Okay, what happens when you read from a nil channel? Blocks forever. Is it the receiver or the yeah, the receiver will block forever. Let's read your explanation. A declared but uninitialized channel is nil, just like a slice. Okay, I already read that. What happens when you send to a closed channel? Panic. Panic at the Disco. Haven't you people ever heard of closing the Dern door? I was obsessed with that band, like everyone else. That song is classic. It's considered retro now, like vintage. Okay, so here's our first challenge: ping pong. I'm gonna pop my XP potion at the end of this, and I should be able to get a level up. This should be the thing here to do it. Many tech companies play ping pong in the office during break time. At Melo, we play virtual ping pong using channels. Uh-oh, I'm scared. Run the code as is. You should see that it doesn't do anything interesting. No ping or pong messages are printed. Fix the bug in ping pong function. Okay. Remember, if the program exits before its go routines have completed, those go routines will be killed silently. Which of the function calls shouldn't run in the background as a go routine? These are channels that don't care what they receive. Go Ponger. And so then it gets down here. This is going to look at all the Pongs. This is gonna go through all the Pong. It's gonna stop at a Pong and wait. And then at the end, when there's no more, so we kill silently. So it needs to. Okay. Um, hmm. This one, maybe? Okay. Oh, I didn't use my XP potion. Oh, wait. Oh, I'm so close. Oh my goodness, we are one XP away from 33. That is wild. I forgot to use my XP potion. Now the universe has said, hey, bro, you have to do the last one to finish off this section. Okay, okay, you got me. You got me. I need one more spoonful of applesauce to get through this. Okay, please don't let this be like a super complicated one. My brain's tired. Textio needs to speed up message processing using concurrency. Implement process messages function. It takes a slice of messages. It should process each message concurrently with the go routine. Okay, so oh, excuse me. Okay, so each time we call messages, um, we get back a message with the word process at the end of it. Okay, so we need to have, okay, you have a go routine that goes over all the messages. This looks horrible. It'd be hilarious if this actually passed the test, even though it's wrong. If only I would be so lucky. What? I don't think, yo, I don't think I did this the way that it wanted me to. I didn't use any Go routines. Um, um, yeah, I think I was supposed to do something like this, or maybe not. Wait, I'm so confused right now. Oh wait, I didn't use any channels or anything. Why is it working? I'm confused. If this passes, I'm more confused. I didn't use a channel for anything. I'm so confused. I'm gonna use one of my things. So for each message, start a Go routine. And Chan. I'm gonna do this the right way. I'm gonna try at least. So we made a channel, and in this Go routine, we're going to take in a channel. In this Go routine, we're going to be able to use the channel. Oh, okay. So we got to do. I ate all the applesauce, by the way. We gotta do a buffer of the length of messages, and then we have to do this over the channel. And then every time the channel receives something, it's gonna um or it's gonna do this thing here I'm confused. I'm a little stuck here. I feel like this is a section that I need to go back and like do some more learning for. We should start a go routine with the loop for each message to call. Okay, so we'll call the process function, and process will take a message. Getting close. Okay, so the channel, um, okay. Um, can I do this? Let's see where we're at with this. Okay. When you use a loop variable inside of a Go routine, make sure to pass the loop variable as a parameter. Okay. So, oh, I see. Okay, so we have to call this channel. We have to define it here, and we also need to put it here. Let's see. Let's get some help. When I went back, I erased the state of my little bot here. So cause of race condition. Oh, it moves on to the next value before the go routine. Oh yeah. Um, that's true. So we should just use this. How would I receive? Um, okay, so let's give it an update. Oh, I see. Okay, I see. Um, do I have to do this? Um, and where- Okay, so cool. Yes, loop to receive all messages from the channel. How do I loop to? Oh, can I? Do I do like the for thing? What was it for? Um, is it like that? Okay, I guess maybe I did that wrong. Let's see. Oh, okay. Okay. Um, was that it? Okay. So so we looped over the number of messages and then we added that message to the process channel by using the assignment operator, and this is how we receive from the channel. So I guess when you receive a message from the channel, it takes it off. Let's ask. Okay. So when you send a message from a channel, it gets added to a queue. When you receive a message, it takes the next message off the queue. Okay. The buffer channel you created. Okay. Cool. So we had that pass. I'm gonna go ahead and what I'm gonna go ahead and submit this. I'm not gonna use a potion because we did make it to level 33. So that was really the goal. And we got, some extra on there as well. So mm, 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 mm. So we finished that whole section. And next we got mutexes. Ooh, mutexes are very different from anything I know. Okay, so we did it. Hurrah, huzzah, hooray. I think there's like a way where I can make my screen like do the celebration reaction. Let's see what that is. There we go. Ah, confetti. Super excited. I am tired as heck, but I'm happy that I did this, and I'm happy that we met our goal. We're like a day late. I really wanted to get this level 33 by yesterday so that it would be a part of the week technically, but a win's a win. A win is a win. A win is a win. Okay, so I am done with this for the night. I'm about to go to bed because I got work in the morning. So I'll catch you all later on. Don't go too far, but whenever you're ready to come back to Wolfpack, I'll be right here. My name's Key, and I'm signing off. Adios.